Okay, so we found what in the last video?
So we found that each tree is going to grow 1/8 of the time.
Each tree is going to grow 1/8 of the time.
So
now,
that means
your initial thought that there might be 1/8 to the 200 trees. This is 1 over 2 to the 600.
That's not
What was your initial guess?
75.
Is 75 more or less than 1 over
It's a lot more.
2 to the 600?
A lot more.
Yeah.
Well,
By the way, 2 to the 10th is about 1,000,
yeah.
right? So this is 2 to the 10th to the 60th. So this is 1 over 1,000 to the 60th power, roughly. So this would be saying, if this was right, this would be saying that in this situation with our trees, you basically would never see a tree.
Yeah.
Ever. Now, do you think that's right?
No.
Okay.
Because, like, with 1/8, so means mostly out of every 8 trees, 1 tree will grow.
Ah, very good. Very good. So each tree has a 1/8 possibility of growing. So that means if you have 8 trees, if we look at just a segment of 8 trees, we expect to see 1. And it definitely does not mean if we look at all 200 trees, like, over the entire life of the universe, if we repeated this experiment every second, we would never see a tree.
So then it would be 200 over 8.
Okay. Which is what?
Which is 25.
25. Okay. Now, your initial guess was 75. Does the answer 25 make sense with that guess?
I mean, like, it makes sense about how I was thinking before that the second restriction takes it down, but it takes it down more than I thought it did.
Yeah, it takes it down a little bit more than you thought, but it doesn't take it down to 1 over 2 to the 600.
No.
It just takes it down from 100. You thought it was going to go from 100 to 75, instead it goes from 100 to 25. So this is a fun example of what's called linearity of expectation. So when you have some symmetry in a problem, once you know 1 tree, you just add them up to get the total expected value. Now, if they weren't in a circle, you wouldn't be able to do it so easily, because there's not as much symmetry.
Yeah, because
If they were in a line like this, because now the endpoints are different than the middle point, so you don't have that symmetry. You can still do a linearity of expectation, but it's just one step a little bit more complicated. But the circle really helped. So it's a fascinating problem. It's a great introduction to linearity of expectation. It reminds me a little bit of that problem from we did 2 weeks ago now on the toad, or what was it, a frog walking, or a turtle? What was walking on the 2017 lines?
yeah, it was a snail.
A snail walking on the 2017 lines. It didn't look like there was any way at all we could approach that problem. We broke it down into some simple cases. It made sense. All right, good working.